Alrighty, here is your video for properties of logs. And if you watched the last video, I talked a little bit about how these properties will also apply for natural logs, which is the log with base of e. So just as a little review, the logarithmic function to the base a, where a is greater than 0 and not equal to 1, we read it as log to the base of a of x. And we talked a lot previously about the connection between logarithms and exponential functions. So today we'll just talk a little bit about these properties of these logarithms and how we can manipulate some of them algebraically. So some basic properties that we've already talked about, and you're welcome to screenshot this as a little bit of a review. Log base a of 1 is equal to 0 because a to the 0 power is equal to 1. Log base a of a is equal to 1 because a to the first power is equal to a. And log base a of a to the x power is equal to x, because log base a of a to the x is the same thing as a to the x power is equal to a to the x power. And then lastly, just our, if I have two logs with the same base here, what they're taking the log of needs to be equal to each other. So to sort of expand on some of these properties a little bit, remember when there's no base for the log, we call it base 10, and that's our common log. So log base 10 of x is the same thing as 10 to the x power is equal to 10. So we would say that this here is equal to 1. Log base 10 of raised to the x power is equal to 1, and we know that anything raised to the 0 power is equal to 1. So anytime, I'll get rid of this so that we can just have a nice fresh copy here. Anytime that our logarithm is equal to 0, we always know that we're taking the log of something that's 1, because anything raised to the 0 power is 1. So some of these logarithms, to split them up here, we can algebraically manipulate, we can expand and we can condense some of these logs. So anytime I'm multiplying two pieces within a logarithm here, we can split that up using addition, right? We know that multiplication is really repeated addition. Anytime I'm dividing by two pieces within a logarithm, we can split that up using subtraction. And if I have an exponent here, I can bring that exponent out front, and that will be equivalent to raising my log to that power. And we'll do some examples so that we can see sort of why and how some of these really work. So looking down here, the product property was this first one that we talked about. So here, this product property. So if I have log base 2 of 8 times 16, I can rewrite this as log base 2 of 8 plus log base 2 of 16. And I know that log base 2 of 8 is 3, and that log base 2 of 16 is 4. So this is really equal to 7 here. But this is what I'm trying to get at, just splitting these up using these log properties. So looking here, log base 5 of 25 plus log base 5 of 4. Here, this first example, I expanded, and here I can use my product property to condense. So this is the same as log base 5 of 25 times 4. So there we can condense. The quotient property is division. So here first I'll expand, and here I'll condense. So my quotient property, this is the same as log base 2 of 16 minus log base 2 of 2. And again, we could continue to further evaluate these. Log base 2 of 16 is the same thing as 4 minus 1. So this will end up getting me to 3. Log base 5 of 25 minus log base 5 of 5. I can use my quotient rule to condense this into one single logarithm, log base 5 of 25 divided by 5. Moving forward, my power property. So I can take my power and I can bring it out front. So this is the same thing as 4 times log base 2 of 8. And if I look at what's really happening here, 4 times log base 2 of 8, this is 4 times 3. And if I think about what this would be, if I rewrite this as an exponential, this is really 2 to the x is equal to 8 to the 4th. And looking here, I can rewrite 8 to the 4th as 2 to the 3rd raised to the 4th power is equal to 2 to the x power. And so I'm doing the same thing here. If I were to simplify these exponents here, I would be doing the same multiplication that I would be doing over here. So just sort of a little bit of background as to how some of these work. 2 times log base 5 of 5, I can condense this into a single logarithm. So this is log base 5 of 5 squared. So again, here I'm expanding, here I'm condensing using those log rules. So if I were to take a look at a nice example sort of all together, here I have log base 2 of 8 squared times x to the 3rd times y to the 4th. I could rewrite this as log base 2 of 8 squared plus log base 2 of x cubed plus log base 2 of y to the 4th. So I can expand, and I'm not quite done because I can take this one step further and say that this is 2 times log base 2 of 8 plus 3 times log base 2 of x. So I'm bringing all these exponents out front here. So I'm using here my power rule and my product rule. So plus 4 log base 2 of y. So there we can expand all together. And remember that these properties also apply to the natural log. So remember this natural log here is log base e. So this is the same thing as log base e of 3x squared all over 5. Just something to sort of keep in the back of your mind. So here I can say that this is the natural log of 3x squared minus the natural log of 5. So this is the natural log of 3 plus the natural log of x squared minus the natural log of 5. And one step further, the natural log of 3 plus 2 times the natural log of x minus the natural log of 5. So here we used all three. So we were multiplying, we had a power, and we were dividing. So just again, the same rules apply for the natural log, and we just went over an example, but if you wanted to screenshot this, you're certainly welcome to. So here I'm multiplying and I'm separating by addition. Here I'm dividing and I'm separating by subtraction. And here I have a power that I'm moving out front. So here are just some other examples. This would become the natural log of 1 minus the natural log of e to the 24th power. And I know that the natural log of 1 here is equal to 0 minus, we could call this 24, the natural log of e. And I know that the natural log of e is just equal to 1. So this becomes 0 minus 24, which is negative 24 if I were to simplify this. I could use these properties to condense if I wanted to. So this could become here, I have a value out front and I have subtraction. So I can use my power and I can also use my division. So here this could be 3 times the natural log of 3 divided by x. And I could take this one step further, plus the natural log of x over 9 here. And I can use my power rule. So this is the natural log of 3 over x all cubed, plus the natural log of x over 9. And excuse me, I can take this one step further here, and I could see that I have both natural logs here and I have addition. So this becomes the natural log of 3 cubed over x cubed times x over 9. And we can simplify this into sort of one last step, the natural log of 3 over x squared when we simplify. So 27 over x cubed and then x over 9 when we simplify one step further. So we can see how this big piece here, using these rules, can turn into something that looks a little bit nicer, and we can simplify. So those are just some examples for you. You'll see you have quite a few problems to do for homework from your text that will just help you really get some practice with these under your belt. So good luck, and as always, please reach out if you have any questions.